Hello, it's time to place some dominoes. Let's play Pips. We've got two puzzles by Ian today, one by Rodolfo. I might have to pause this and take a break if I get a scheduled phone call early. We'll see. Try to finish this in time. Let's start with the easy puzzle. Let's start solving. Okay, we need to make 15, which will be all three of our fives. That's certain. So that means we'll connect the 3, 5 here. And then we have a double 5, so that goes there. We now need our only other 3 here. So we need a 2 coming out of the equivalence region, and then our less than 3 is made up of 2 1s, and that might as well have been a void. And there we go. That was the easy puzzle. Let's try medium. All right, look at this. We've got a diamond or an O. Right. Okay, so we have 3 of something and a 0. Oh, and the 0 connects to another 3 of something. So, and we only have 1 0. Okay, well, one of these, well, it can't go this way because that'll block off that little peninsula down there. So 0, 4 goes here, and we have 4s in this region. That is confirmed, which means we need a different 3 of something down there, and it connects to a greater than 5. Well, it can't be this 4 because we don't have enough 4s to manage both of those regions. Could it be 2? Oh, and whatever it is, it'll need doubles. Yeah, actually, it would. Yes, it must be 2s. The 2s are the only things of which we have sufficient quantity and a doubled domino. So it is that. We also that forces another doubled domino here, right? So this is all sort of flowing very, very logically. So then we've got 2 1s there. We need less than 11. That's an interesting one. Less than 11. We also need to finish our 4s off here. We have several possibilities, though. Well, we need 1 4 connected to a greater than 4, actually, and there are still 2 ways to do that. Still 2 ways. And then yet another 4. Okay, so another 4 connected to. So this probably still ends up being fairly constrained. I'm guessing the greater than 4 is the 5, but we'll see. Oh no, maybe it's not. Well, no, it might not matter very much. Because, yeah, this is fine. I mean, there are probably several ways to do these final bits. But yeah, the 4 connects to a 3, less than 11 is a 2. I mean, we were well less than 11 there. So that's why there would have been a few different ways to solve that. Anyway, that was the medium puzzle. We'll move on to the hard. Let's start solving. We've got a big U in the grid here. Oh, wow, look at this. 6 cells making up a total of 12. And then we've got 2 different 2 size 12 regions. So those require the maximum. Those require 2 6s each. Oh, and then a 0. Right. We've got a lot of extra. Oh, no, sorry. We have 3 groups. 3 pairs that add to 12. So we have 6 6s. No, well, yes, we have 6 6s accounted for in total there. Let's see how many we have. We only have 6. Right. So one of them will be a doubled 12. And then the rest will obviously use the other 6s. And then we've also got 3 zeros here. How many zeros do we have? We only have 3. So yes, again, those are all spoken for. Do any of those zeros yes. Okay, so we have a 0, 6. That's good to know because that goes here or here. It must do because we have precisely the required number of zeros and 6s. We cannot waste any. So it goes in one of those positions. I don't know which, but I'll just leave it there to remind myself that it's used. And then the 10, because we have no 6s, the 10 can be made only of 2 5s. And it looks like we don't have those in a single domino. We do have 3 5s. So we have a 5 6. So in theory, we could put the 5 6 there. But because we have more than 2 5s, that might not be strictly required. What about this 12? This is interesting. We don't have any zeros. So each one of these cells is at least equal to 1, but could be equal to more than that. So, if we had, well, how many 1s how many 1s do we even have? Let's actually figure out how this might work. Because, we could have 6 2s in there, in theory, but there probably still are several ways to make this. But the thing is, we only have 3 1s. So we could put 1 1 1, 2 2, then we could still have 5 in the last remaining cell, so it's not very limited. It's not very limited. Okay. Right. What about this 12? This could be the double. Well, actually, in the current arrangement, it has to be. So if this 5 6 connects, if that's true, which it might not need to be, but if it is, this must be a double 6, for what it's worth. We also have, this 3 region here might as well be a 1 equivalence region, because we have no zeros. So only ones, and we don't have, right. No, that's incredibly important. This is a great puzzle. So because there are no zeros to use, this 3 region is made up of 3 ones, but we only had 3 ones. So that means this 12 is made up of nothing but 2s. It may as well, again, be a 6-sized 2 equivalence region, because with no zeros or ones, that's the only way we can avoid blasting past the count of 12. Right, so that means this, if this is true, this double 6, which is still my supposition, but not proven, we then need a 2 connected to a greater than 3. Couldn't be a 6 because all of our 6s are spoken for, so it could be this 4, 2, 4, and in fact, it needs to be. That's the only possibility in this world. Then we would need this double 2 here. Then we would need a 2 connected to a greater than 2, which could be 2, 3, not 2, 6. It has to be this 2, 3. Wow, it's all happening. Then we would need the 2, 6 finally. And then we could do a 2, 5 or a 2, 0, depending on what we have available. We do have a 2, 0. It looks like we don't have a 2, 5, so I think this would need to go here in this world. Let's see. We would need a 1 connected to a less than 4. I don't think we've done anything that needs us to be saving our 3s for anything, so that works. In fact, it's the only thing that would work. Then we would need a 1 going to a greater than 4, which is a 5. Then our 1, 4 puts the 4 into the void. That just goes there. Then we would need... this is not possible. This would never have been possible, actually, because it would have required another 6, 0, because, it's how the geometry would have worked. Is that true that never would have been possible? Could I have arranged these? No, that's not true. These could have been arranged something like this. It doesn't work with the configuration of dominoes we have, but in theory, that would have been a possible way to do it in a different situation. Anyway, that's fine. That's there. So our last 0 goes here, our last 6 goes here, and our last 5 goes here. That was a really fun hard puzzle, and there we have it. That was a full day of pips, and I got it done on time. I really enjoyed this one in particular. I thought that was really fun. All right, hopefully you enjoyed it as well. I'll be back tomorrow for more dominoes, more pips. Join me then. Bye for now.